Hey guys, welcome to question 11. So starting off with part A. So express 3 minus I over 2 plus I in the form x plus iy, where x and y are real numbers. So writing what we have down for part A, we have 3 minus I over 2 plus I. So when we want to make these into a singular complex number, well, the main idea is to basically find the conjugate of the bottom. So as you can see, it is 2 plus I, and then multiply by the conjugate on the top and bottom. So 2 plus I has a conjugate of 2 minus I. So multiplying those, we have 3 minus I times 2 minus I. Now when you have a difference of 2 squares with complex numbers, we have 2 squared, which is 4, and plus I times negative I is going to be plus 1. So simplifying the top and simplifying the bottom goes to 5. So 3 times 2 becomes 6. 3 times minus I becomes negative 3i. Negative I plus 2 is negative 2i. And negative I times negative I is just minus 1. So simplifying it down, we have 6 minus 1, which is 5, minus 5i over 5. And finally, that becomes 1 minus I. And that will be it for part A. So next, for part B, we have an integration of trigonometry. So as you can see here, we have evaluate the integral of sine cubed 2x times cos of 2x. So looking at it, well, we can see that sine has a cube and we have an extra cos at the end. So that might hopefully give you an idea. So for part B, that we will use u substitution for sine 2x. So using this, we can, well, first differentiate both sides. So du over dx equals, that will be 2 cos 2x. And then we can just write du as 2 cos 2x dx. So looking at the integral, so the integral of sine cubed 2x cos 2x, that can be replaced with, so sine cubed gets replaced with u cubed, and well, we meant to replace cos 2x dx, but we have an extra 2 up here, so we just put a half in front for du. And well, let me rewrite that so it's easier to see. So u cubed times half is just, well, u cubed over 2. So, well, that's a pretty easy integral. So remember your rules is you add 1 to the power and divide it by the same power. So u to the 4 over 2 times 4 is 8 plus c. And well, we gotta put it back because this is an indefinite integral. So remember our u was equal to sine 2x, hence we put sine 2x to the 4 over 8 plus c. And that will be it for part B. So next for part C, we have two parts, Ci and Cii. So for Ci, write the complex number -3 plus I in exponential form, and II, hence find the exact value of that to the power of 10, giving your answer in the form x plus iy. So let's start off with part I. So part C, I, we have write the complex number -√3 plus I in exponential form. So exponential form is when you have a complex number, let's say z, in the form of r e to the I theta. So r is given by the modulus of z, and theta is given by the argument of z. So this should hopefully be pretty easy to see. So first we got to find the well, modulus of our complex number. So modulus of negative 3 plus I is just going to be the square root of, well, root 3 whole squared plus 1 squared. So if you guys can see, that is just going to be 3 plus 1, which is root 4, which is overall 2. So we know that the modulus, or r for the exponential form, is going to be equal to 2. So next is the argument of z. So we want to find the argument of, let's see, was it, oops, sorry, negative root 3. Negative root 3 plus I. So if you get a sort of diagram for it, you can see that you'll have negative root 3 plus I root 3, which is 1. So the argument of that is just going to be, well, pi minus whatever this angle is. So if you guys know your rules, that's just 1, that's root 3. So tan inverse 1 and root 3 is just pi over 6. So the argument of this, which is when you have the positive axis to the right all the way through here, is going to be pi minus pi on 6, which is 5 pi over 6. Therefore, the theta, or argument, is going to be 5 pi over 6. And hence, if you write the exponential form of negative root 3 plus I, that's just going to be 2e to the I times 5 pi over 6. So now, next for part II, we want to find the exact value of, well, this, giving your answer in the form x plus iy. So, well, hopefully you can see that we can make it a lot easier by just using our previous part. So we know negative root 3 plus I is 2e to the I 5 pi over 6. And then just do that to the power of 10. So, well, we can simplify it by just putting our power rules in. So that's going to be 2 to the power of 10 times e to the I, well, 50 pi over 6. It's a bit of a big one. So that is going to be equal to, let's see, 2 to the power of 10 times e to the I, that will be 8 pi plus, let's find that's 2 pi over 6, which is pi over 3. Put all in brackets so you can see it. And, well, any sort of rotation of 2 pi, so 2 pi, 4 pi, 8 pi, 6 pi, anything like that, is just going to be the same as if you didn't add it at all. That's why we can just say that this is the exact same as 2 to the power of 10 times e to the I pi over 3. And if you remember your modulus argument form, so that's 2 to the power of 10 times cos pi over 3 plus I sine pi over 3. And if you just hopefully remember this, so cos to the pi over 3 is going to be equal to 1/2, well, that is not a half, plus sine pi over 3 is just going to be equal to I times root 3 over 2. And if you times it out, that is just going to be equal to, well, 2 to the power of 10 divided by 2 is just 2 to the power of 9, plus I times, well, root 3 over 2 times 2 to the power of 10 is I times 2 to the 9 times root 3. And that will be it for part II and part C in general. So next for part D, we have a triangle is formed in 3-dimensional space with vertices A, B, and C with those coordinates. Find the size of angle ABC, giving your answer to the nearest degree. So we have a set of 3 points in three-dimensional space. So I'm going to write them here. So this is not the scale at all, so please don't use this as a scale. We have A, B, and C. And we want to find the size of angle ABC, which is from A to B to C, which means that it's this angle here. So let's just let this angle be theta. Not sure what it is. Could be acute, could be obtuse. We're not sure. This is not the scale again, so please don't be confused. So when you see vectors and an angle between like two vectors or whatever, I want you to immediately think of dot product. Because when you have a dot product, well, an angle can pop out. So looking at the vectors we want to use these two probably. So BA and BC. Hence, if we use the dot product, so BA dot BC is equal to the magnitude of BA times the magnitude of BC times cos theta, where theta is the angle between them. So now we can just rewrite that as cos theta equals BA dot BC over their magnitudes. And now we just need to find BA and BC. So BA is equal to, so OA minus OB, so 1, negative 1, 2, minus 0 to negative 1. That's just going to be, so 1, negative 3, and 3. And for BC, same idea. You do from C to B, or C minus B. So C is given by 2, 1, 1, minus B, which is given by 0 to negative 1. And if you do the math, that's 2, negative 1, 2. So that's our BA and our BC. So cos theta is equal to, let's see, 1, negative 3, 3, dot 2, negative 1, 2, over the magnitude of them. So if you do the magnitude of, let's say, BA, that's going to be square root of 1 squared plus 3 squared plus 3 squared. That's technically negative 3 squared, but you know that's the same thing. Times square root of 2 squared plus negative 1 squared plus 2 squared. So simplifying the top, 1 times 2 is given by 2. Negative 3 times negative 1 is plus 3. And 3 times 2 is plus 6 all over. So 1 squared plus 3 squared plus 3 squared is root 19 times 2 squared plus 1 squared plus 2 squared is root 9, which is 3. And overall, we have 11 over 3 root 19. So cos theta equals 11 over 3 root 19. Now we just find theta, so cos inverse of 11 over 3 root 19. And that will give us, you pump this in your calculator, so make sure this is in degrees, and that will give us 32.73, some very large number. So obviously this will round up to 33 degrees, which is here. So nearest degree. And that will be it for part D. So next for part E, we have let L1 be the line with equation xy equals negative 1, 7 plus lambda 3, 2. Lambda is real. The line L2 passes through the point A, so negative 6, 5, and is parallel to L1. Find the equation of the line L2 in the form y equals mx plus c. So we know that L1 is the equation with, well, line of equation, negative 1, 7 plus lambda 3, 2. So L2 passes through the point A, negative 6, 5, and is parallel. What that means is we can write L2 as the line with equation xy equals. So the first part of the equation for these sorts of vectors is the position. So what kind of line does it pass through? So for line 2, that passes through -6 and 5. So next is the direction vector. So what's the direction that it's going through? Since it's parallel to L1, we can see it says right there, parallel to L1. That means it has the same direction vector as L1. So the direction vector is 3, 2. So we write 3, 2. And hence we can write L2 as the line with equation xy equals -6, 5 plus lambda 3, 2. And finally, to find the line L2 in the form y equals mx plus c, well, we have to just find out the equations x and y separately. So x equals -6 plus 3 lambda. So we're expanding the vector equation above into two separate equations. So y equals 5 plus 2 lambda. And what we do is we just make each side equate lambda. So just make first one down. So x plus 6 over 3 equals lambda. And for y, we have y minus 5 over 2 equals lambda. And therefore, we can sort of equate both sides like this. So now we just, well, make this into the form y equals mx plus c. So first, to make both sides nicer, I'm just going to times 6 everything. So times 6 to all of the terms. So 3y minus 15 equals 2x plus 12. 3y equals 2x. C plus 12 plus 15 is plus 27. Finally, y equals 2 over 3x plus 9. And that will be our answer for part E. So for part F, our final part for question 11, let's scroll down a bit. We have, using the substitution t equals tan x over 2, find the integral of dx over 1 plus cos x minus sin x. So when we see our t sub here, so t equals tan x over 2, we want to immediately express all our terms of sine and cos in terms of t. So if you guys, you might just have to memorize these later on, but we have sine of x is equal to 2t over 1 plus t squared. Cos of x is equal to 1 minus t squared over 1 plus t squared. And finally, we can rewrite dx as 2 over 1 plus t squared dt. If you guys don't understand where these derived from, I'll maybe make a video later, but just know these three sort of equations for, oh, I nearly forgot, part F. So using that will make our equation here much more easier to deal with. So rewriting everything we see here, we have, let's see, I'll write this as 1 over 1 plus, so cos x is 1 minus t squared, 1 plus t squared. And minus sine x is minus 2t over 1 plus t squared times dx. So dx is replaced with, like I said before, 2 over 1 plus t squared dt. It's a bit of a long one, but overall it isn't too bad. So if you guys can hopefully look at the working out, let's times everything here on the left side by 1 plus t squared. So that's the same as 1 plus t squared over 1 times 1 plus t squared is just 1 plus t squared, plus 1 minus t squared minus 2t times 2 over 1 plus t squared dt. So I just times everything on the left fraction by 1 plus t squared. So now you guys can see that hopefully this and this cancel out. So the 1 plus t squareds cancel out. And we have 2 over, so now we should simplify the bottom. 1 plus t squared plus 1 minus t squared minus 2t. So that's 2 minus 2t all times dt. And thankfully, that's pretty easy to, again, simplify. That's 1 over 1 plus 1 minus t dt. And hopefully you guys can see that we just, well, if we differentiate the bottom, we have a negative on the top. So let's just put negatives here. So put two negatives to cancel out. And now that's just going to be negative ln of the bottom. So 1 minus t plus c. And don't forget, this is one of the biggest things that happens in t-sub. We subbed in t, but the entire thing was meant to be in x. So we finally rewrite negative ln times 1 minus, what was t? That was just tan of x over 2, absolute, plus c. And that will be our answer for part F.